today's lesson is 1.1 Rational Numbers. It's the very first lesson in Unit 1. The I can statements that we're going to be able to say that we can do when we're done with this lesson are: I can classify a number as rational or irrational based on its decimal expansion. I can convert a repeating decimal into a rational number. Key terms that we need to know: rational number, integer, which is all whole numbers and their opposites, a terminating decimal, that's a decimal that stops, and a repeating decimal, a decimal that repeats, 0.12, 12, 12. The repeating part is the 1, 2. Now for those of you in Avid, the summary part is something you do after we take notes and you come back here to write complete sentences in your own words. This is something that the Avid kids do. This is something that we all do every once in a while in class as a class together to talk about what we've learned in our notes. Okay, next page. Your vocabulary, you need to write this down. When we were talking about vocabulary, we're talking about today is a rational number. That is a number that can be written as a fraction, meaning or division of two integers. And integers are all your numbers on a number line. Examples of rational numbers are a negative 3/2, it's a fraction, 1/9 fraction, negative 5/1, because a negative 5 is an integer, it's a negative integer. To make it into a fraction, you just put a 1 under it. All whole numbers can be made into fractions, so they are all rational. We'll be getting into it later as well, but any perfect squares, the square root of 9 equals 3. You get a whole number. Those are all rational as well. All right, the practice. Some of these, it says you divide the number by the denominator. Methods. Today you're not allowed to use calculators. You have to show long division. It says write each fraction as a decimal. If I have 13/25, the top number, your top dog, 13 divided by 25. 13 is your dividend, 25 is your divisor. Now we all remember long division. Put your decimal as many zeros as you need. Bring your decimal straight up. Now 25 doesn't go into 13, but it does go into 130. It goes into 13 0 times, but it goes into 130 how many times without going over? That would be 5 times. 5 times 25 is 125. Subtract 130 minus 125 is 5. Bring down a 0. Now 25 goes into 50 twice. 2 times 50, 0. So our answer, 13/25 as a decimal equals 0.52, and we say that 52 hundredths. Now, if you look at this, you want to try to look at your denominator. Anytime you can turn your denominator into something that's either a 10 or a 100, you're going to save yourself all this time on the long division. So if I would have had 17/25, I look at that and say, hey, I can turn this 25 into a fraction with the denominator of 100. Because 25 times 4 is 100. 17 times 4, 68. All right, so now I can say this as 68 hundredths. That's the same as 68 hundredths. So you can do all that and save yourself all the long division. All right? Next one. Now anytime you see a number with a denominator of a 9, we know that's going to be a repeating decimal. All right? So you're going to take 7/9, and that's going to be 0.7 repeating. can't just be 0.7 by itself because that equals 7/10. So that would be 7 over 10. But if it's 7 with the bar notation, the 7 repeating, you always know that that's equals 7/9. And if you forget, well, top dog, 7 divided by 9, if you did the long division for it, 9 goes into 70. How many times without going over? Excuse me. 7 times 9, 63. You subtract, you get 7. Bring down a 0. Again, 9 goes into 70. Excuse me, 7 times without going over again. 63, what happens here? We just end up repeating. So what is our answer? 0.7 repeating. Just like we said, right here and right here. Anytime it's over 9. You'll see other examples where you might have 17 over 99. That would be 0.17 repeating. Anything over 9 or 99, those are repeating decimals. All right, 5, 6. There's really no shortcut because I can't turn that into something, that 6, that denominator, into a 10 or a 100. So we're having to do the long division. 5 divided by 6. All right, 6 goes into 5, well, 0 times. But 6 goes into 50, how many times without going over? 6 times 9 is too many, right? 6 times 9, 54. That doesn't work. So what are we going to try? 6 goes into 5 0 times. How about 6 times 8? Does that work? 6 times 8. There we go, 48. Okay, so 50 minus 48 is 2. Bring down your 0. Now 6 goes into 20. How many times without going over? 3 times. 3 times 6, 18. Subtract, you get 2. Bring down a 0 again. 3 times. Oh, so we have a pattern going on here now where the 3 is going to keep repeating. So 5, 6 as a decimal equals 0.8333. All right, that 3 keeps repeating, so it is 0.83 with the bar notation over the 3 only. If you were to put it over the 8 as well, you would lose a point or half a point on your papers. So make sure you only put the bar notation over the number that repeats. All right, and then the last one, 5/12. Again, we can't turn 12 into 10 or 100, so we're going to have to do the long division.
Jack Olson, Drayton Cook, please come to the office.
Oops, sorry about that. In between bells here. So again, we have 12 divided by, oops, my bad. Bells got me all flustered here. 5 divided by 12. Add your zeros. 12 goes into 5. 0 times. How many times does 12 go into 50 without going over? Well, it was 12 times 3. 12 times 3. 36. Is that enough? Well, what's 12 times 4? There we have 48. Aha! So we're going to want to use the 4. 12 times 4 is 48. Subtract. We get 2. Bring down a 0. How many times does 12 go into 20 without going over? Once, for sure. Twice is 24. That's too many, so 1 time. 1 times 12 is 12. Subtract. You get 8. Now we're going to need another 0. How many times does 12 go into 80 without going over? Well, what's 12 times 5? 10. You get 60. That's not enough. Well, if we double 4, and make it 8, that's going to be way too many. So maybe we want to try 12 times 6. What do you get? Aha, 72. Now we're talking. So it goes into there 6 times, and that would be 76. Or 72, my bad, 72. Subtract, and now what do we get? 8 again. So we're going to end up repeating with that 6, because it would have kept going 6, 6, 6, 6, 6, and so on. So we write that as 0.416 with the bar notation only over the 6, because that's the only part that repeats. Now, this part, we're going to do the opposite. We're going to write each decimal as a fraction or a mixed number in lowest terms. Now we have this number right here, 0.34. You say that number 34 hundredths. So you say your fraction when you say the decimal. 34 hundredths. Those are equal. Now we simplify. Well, they're both even, so divide by 2. And we get 34 divided by 2, 17. 100 divided by 2, 50. And that is in simplest form. We go down here. We have 3.125. So that means I have the whole number 3. 3, the decimal stands for and, so we have 3 and 125 what? Tens, hundreds, thousands. So we have 125 thousandths. Now we simplify that. It will be 3 and what can we divide by? We're going to divide by 25. Sounds good. 125 divided by 25 is 5. 1,000 divided by 25, well 25 goes into 100 4 times and we've got our 0, so that's going to be a 40. But are we done? No. We can still simplify 5 40ths. Divide by 5. Divide by 5. So I still have my 3, and 5 divided by 5 is 1. 40 divided by 5 is 8. So we have 3 and 1/8. That is the same as 3.125. They are equivalent. They're equal. Repeating decimals. Now we talked about the 7/9 earlier. So if in that earlier one, if 7/9 equals 0.7 repeating, what do we know here then? If 0.2 repeating, that is 2/9, and that is simplified. Now here, what are they telling us? 1.1515, and that dot, dot, dot means it's repeating. It just keeps going on and on. But it's only the 1.15 that's repeating, all right? So we have our whole number 1, and now 15 doesn't go over just a 9. We have 2 digits, so it goes over 99. Can that be simplified? Yes. You remember the divisibility rule of 3, 5 plus 1 is 6. I know 3 goes into that. 9 and 9 is 18, 3 goes into that. So, divide by 3. 15 divided by 3 is 5. 99 divided by 3 is 33. And then we have our whole number 1. 1 and 5 over 33. 5 33rds. And now we have this one. 4 and 123 thousandths repeating. 123 thousandths, but it's repeating, so it's not 1,000. It's not over just 9, and it's not 99 like up here, 999. Now it's 999. Can we simplify that again? Yes. 3, 2, 1, that's 6. So divide it again by 3. What will we have? 3 goes into here,